Hey guys, this is lesson 6.3, graphing radical functions. So first let's just briefly describe what a radical function is. And it's a function that contains a radical expression with the independent variable in the radicand. So the independent variable for us is usually x, and being in the radicand means that it is under the radical symbol. For example, over here on the left, we have a square root function. So our square root function, this is what the parent function graph looks like. All right, for f of x is equal to square root of x. How do I know this is a square root? Because if it doesn't have a little floating number out here, then it's considered a square root. You could go ahead and write the 2 there if you wanted to, if that helps you remember that it is a square root. But it's not typically written. It's one of those implied things, kind of like ones in front of x's as a coefficient. So let's talk about the graph. You'll notice that the graph starts at 0, 0, and it continues kind of up and to the right. So it's going towards positive infinity in the x and the y direction. So the graph, the square root graph, starts at 0, 0. And because it doesn't have any negatives, it doesn't have any negative x's, negative y's, our domain for this graph, x, remember domain is always x values, is going to be greater than or equal to 0. So it starts at 0 and it gets bigger. The same thing with our range. Our range starts at a y value of 0 and it increases. Just to remind you, when we read from left to right, that's actually our domain, our x values. And when we read from bottom to top, that's our range or our y values. Now, our square root function can be transformed, and when it's transformed, if the whole function gets moved up or down or left or right from a transformation, then that can change our domain and range because it's moved our starting point. So let's just kind of summarize that. So transformations, which we're going to talk about in a minute, transformations can change the domain and the range, the D and the R. And that is because we are moving the starting point. Since we have a distinctive starting point, if we transform the function by shifting it up, down, left, or right, that changes our domain and range. Now, let's look at a cube root parent function. So the cubed root parent function is the cubed root of x. How do we know it's a cubed root? It's got a 3 here as the floating number in front of x. Remember, that's called the index, that floating number. Now, if we move this parent function up, down, left, or right, this kind of center point here at 0, 0 is going to move. However, you'll notice that this graph goes as far as you can think to the left, as far as you can think to the right, and eventually, even though it's not real steep, it is going to go to positive and negative infinity in the y direction as well. So our domain here is all real numbers, and so is our range. And a transformation, just by shifting that center point, not a starting point, but a center point, up, down, left, or right, that's not going to change it. Okay, so transformations do not change our D and our R, our domain and our range, when we are talking about a cubic function, because our domain and range to start with is all real numbers. And so that doesn't change by just shifting that center point.